I didn't realize that, 8 or 9 planets, we're talking about our solar system, and that our solar system is one of billions. Understand? And it is in a galaxy that itself is one of billions. In fact, people think trillions of galaxies are there. So when I learned about that, it was just truly like, you can spend your whole life studying this stuff and there would still be more to discover.
Hello and welcome to Void Deck, a casual science podcast brought to you by Science Centre Singapore. I'm your host Rishi from Science Centre Singapore, and today we're joined by my colleague Xiaoxin from the Education Department in the centre.
Hi everyone, very excited for today's episode.
Today we're going to talk about Spacetech. So Singapore is often called the little red dot because of how tiny we are. But did you know that Singapore is home to a number of space tech companies vying to boldly go to the frontier of space?
So in this episode, we chat with Dr. Christopher Luwanga, the CEO and founder of Galamad Aerospace, based in Singapore.
If you want to support more electrifying talks with Singapore-based scientists, share this podcast with a friend and show us some love with a 5-star rating. Thanks for tuning in and exploring the universe from the heartlands. Let's get the podcast started. So, hi, Christopher.
Hi, Rishi.
And thank you so much for joining us today. I'm sure you're busy, running your own company. I think before we jump into all the intense space talk that we want to, discover today, I just wanted to know more about you, Christopher. Like, what were you like when you were a child? And, did you always want to do space when you were growing up?
Hello, everyone listening. I'm Christopher from Malawi. That's where I grew up. Malawi is in Central Africa, Southeast Africa. I've met a lot of people and I said Malawi is in Southern Africa, and someone says, is it South Africa? I said, no, actually, it's a completely different country. So it's a small country, but certainly not as small as Singapore. When I was younger, actually, I was interested more in literature.
Oh.
So by the age of 9 or so, I used to actually read a lot of Shakespeare. So Macbeth, for example, is one of the books I remember when I was very young. I read that book and I took it to class. And the teacher was like, how can you be reading this book? Because it was like no one else in my age group read books like that. So in my younger days, really was more that. And I used to write poems. So our country organizes education days. And education days, you could perform an existing poem, or in my case, I wrote my own poems and then went and performed those poems in front of a lot of people. So I was famous for that, for writing poetry, actually. And so it was literature, I'd say.
So you're telling me at 9, not only were you reading Shakespeare, but you were also writing your own poems.
Yeah, actually,
okay.
It was just not something that I had planned per se. It's just that I didn't really have, I guess, a lot to do. so I grew up on a farm and all that. So in my free time, I used to read the dictionary.
Wow. Okay,
so
the dictionary.
I memorized and knew a lot of words. So that allowed me to be able to both speak well enough at an early age as well to be able to write. Very young, I actually had people from the main radio station in my country come to my village just because they were surprised that someone can speak English in that village that well. So it was because I had not much else to do. So I read a lot and I was able to, write also.
Xiaoxin, what were you doing when you were 9? I'm just clarifying that we all didn't.
Sad to say, I think I was watching cartoons mostly.
Yes, and I think the books that I was reading at 9 were probably half as thick as the books that you were reading. It was probably Mr. Midnight. I mean, it's a very childhood horror book that's very famous among kids here, but never Shakespeare. But wow, that's very impressive. So how did you, I guess, pivot from literature, which is very artsy, how I grew up, into STEM, right? I mean, space is, and I'm assuming physics is involved as well. So how did you make that pivot all of a sudden?
I think it was not really one moment. When I went to high school, I became more and more interested in science, mostly from an engineering point of view. Looking at what people have built, that excited me.
From lit STEM, that's actually a big pivot.
Yep, that is. From Shakespeare to space.
Yeah, from Shakespeare to space. It's super cool that, you could actually make that pivot so seamlessly. And so you were saying that you were into like engineering, right? And how did that evolve into like specifically like, space tech or like wanting to do something related to space? Was there like a moment in school that, like kind of inspired you, or was it just something that you just stumbled upon?
I would say more stumbled upon. When I was younger, even in my high school days, I really hadn't had a lot of inspiring figures or anything to do with space. So I was not like enthusiastic about space movies. I was not interested in what happened for us to get here in terms of space. But I think sometime in my late teens, I realized that there were not 8 planets or 9 planets. And it's a trivial thing, but all my life up to that point, I actually thought that there were only 8 or 9 planets. Okay. It was because in primary school, of course, we're very young, so they don't really say that it's 8 or 9 planets in our solar system. They just say 8 or 9 planets. I didn't realize that, 8 or 9 planets, we're talking about our solar system, and that our solar system is one of billions. Understand? And it is in a galaxy that itself is one of billions. In fact, people think trillions of galaxies are there. So when I learned about that, it was just truly like, you can spend your whole life studying this stuff and there would still be more to discover. So it was more, I guess, like this would be very interesting. I could spend my life doing this and there would, I wouldn't get bored, in other words, right? I just felt it was very untouched as a field. There wasn't a whole lot. Like I said, me growing up, I didn't know a thing about this whole universe beyond our 8 or 9 planets. So it was, I guess, logic-based. Just I'd like to do something in this area.
Right. I mean, when you put it that way, I mean, it's crazy to think, right? Like you're saying, like there's maybe billions or trillions of like, like planets and solar systems out there, and we're just like this tiny person in this little red dot right now. So that was a very interesting, insight into how you got into space. So maybe we can like, talk more about Galamad Aerospace, the Spacetech company that you founded. What is the origin story of this company, and what motivated you to start this company?
So when I came to Singapore in 2018 to do a PhD, luckily I was also involved in building satellites. So during the 4 years that I was doing space physics focused research, so even though I was in the School of Electrical and Electronic Engineering, my research was a bit more on the science side. But luckily, concurrently, I was involved in engineering work. So, while doing that engineering work, I saw that we could certainly do more using a different business approach. Okay. So traditionally, satellites have been very, very expensive. Okay. And only a few countries have really built their own satellites. So, for example, across Africa, very few countries have actually built satellites. And sometimes when you hear it, so and so has built a satellite, often just means they bought. Okay. And then, so in reality, very few people are involved. But I also know that in order for us to do anything meaningful in this space, you need an enormous number of people. Right? Because today, even though NASA, of course, is a big organization, in the grand scheme of things, is very tiny in the number of people that actually work on space, right? So I felt creating a company that's focused on how we can do things at scale, right? Like instead of, just building 5-10 satellites a year, how can you create a company that allows us to build things at a significantly larger scale? Because in the process of building, you learn more about building itself, right? So if we want to go to Mars, for example, there is no way we're going to go to Mars with only one main company. Building a city on Earth requires an enormous number of companies, right?
Right.
Building a city on a different planet will require a significantly larger number of people involved, a significantly larger number of companies involved in resources. So our company is just, preparing for that eventual future where we're exploring beyond Earth. And in our own way, we believe that we can make that contribution by involving as many people as possible, both here in Singapore as well as I mentioned, as I'll mention later on in other parts of the world.
Christopher, I have an interesting question. As you were sharing about improving the access to space and space tech, you spoke about big scale. So why base your company in Singapore, which is a small nation?
Well, it's a small nation, but not a small people, right? In the sense that it's geographically small, but obviously it punches above its weight in a lot of ways. And one of them is certainly in terms of talent access. Okay, so there is a significant amount of intellectual resources required to build satellites, right? And often it's very hard for me to just go into any ecosystem and find that already there. So because Singapore has already built, people want to come to Singapore for their own reasons, one of them being money, right? So they come here for those reasons, but the talented people are here, right? So by basing 1 foot of our company here, it allows us to access that global talent. So in a manner of speaking, there is, I guess, knowledge that we need here. That's one of the primary reasons that we based ourselves here.
Wow, that's an interesting
My
insight.
key takeaway is he said that we are talented people.
Yeah,
So
you and I.
thanks for making my day, Christopher.
Absolutely.
Can you tell us more about the spacecraft that you are creating in your company?
So as in a company, you start off with a vision, and our vision is to build the satellites that we're basing on what we call PROSat. PROSat, the P stands for programmable, the R stands for reusability, and the O stands for orbitless. Programmability just means that it's able to be reprogrammed to do something else. Okay, for example, yesterday I wanted to use the satellite for doing TV transmissions, but today I'd like to use it for carrying internet traffic, for example. Okay, I would like to be able to program while it's already in space.
And you mean to say that at the current state, most of the satellites are built with a specific use in mind and is usually not repurposed?
Absolutely. Almost all of them are built that way.
So once it's out there, it only functions as one purpose. Like, for example, you said TV transmission, right?
Yeah,
It can't do anything else except be for TV transmission.
correct. That's all it would do. And after it's done with this job, it's thrown away.
So for perspective, do we know how many satellites are there around Earth right now?
Yeah, thousands. In the near future, we're looking at possibly 50,000.
Oh.
So since 2019, between 2019 and now, we've launched more satellites than we had launched from 1950s to 2019.
Oh, okay.
So in the last 6 years or so, 5-6 years, it's been a significant increase in order to support specific applications. In this case, the application of telecommunications or carrying internet data through satellites. That requires a large number of satellites. But moving forward, our business is also going to build lots of satellites. And that's why we have the reusability element to be able to both reuse the satellites as well as, if needed, we bring it down. So we just don't throw it away. But the applications that we are looking at require a lot of satellites. So moving forward, we're expecting not fewer satellites, but a significant increase in the number of satellites that are out there. I should mention, however, that when you see people talk about space debris, that is trash in space, that's a valid concern, but at the same time, somewhat overblown sometimes. Space is big, okay? So the surface of the Earth is, whatever size it is, imagine you have many shells of bigger sizes all over, right? So it's not that if we have, for example, so on Earth, as you know, we have 1.2 billion cars, okay? It's not that they're always ramming into each other. There is some level of organizing that we would need to do in space, okay? In other words, we don't necessarily reduce the number of satellites, but we create infrastructure that allows us to manage the traffic in space appropriately. So if your satellite is coming from mine, I should have a built-in ability to avoid it, right? So that's the component that in our PROSat, the O part, but orbitless, to give it autonomy, say, okay, I see something coming, I should avoid it. And this doesn't require new inventions, really. Okay, we already have what we call thrusters, which are little small engines. You turn it on, it will change your location so that when the thing comes, you will have avoided it by the time you meet and so on. So just doing things at a bigger scale and managing the traffic appropriately is the way forward.
So right now, do the satellites just like drift, I guess, like aimlessly, and they do like, I guess, bump into each other? Or like, how do they avoid like hitting into each other right now? Like, because it's something that you said is you're working on, right? And is it something that's new, or do many companies already try to do this? Because I'm just imagining like a bunch of satellites in hovering above Earth, just like bumping into each other and just like crashing. And
so to actually bump into another satellite, you would have had to make so many mistakes on Earth in your design overall systems so before I launch, actually, I know where other satellites are. Okay, so there's a coordinated system where every satellite is given its own orbit. And so when I say that my satellite is in an orbit of, say, 580 kilometers, and this is the inclination and so forth, these details, you know that they would not conflict with another satellite. Okay, so only in scenarios where something has happened, that is, your orbit has somehow been disturbed by natural forces or artificial forces, that's to mean maybe an attack of sorts, then you might have issues. So in general, it is very, very unlikely that you would have a satellite hit you. Okay. What might hit you though is if a satellite breaks up. Okay. For example, there are some tests some countries are doing for their own reasons, for military reasons. If they hit another satellite, break it up, then those pieces, their trajectories are a bit less predictable.
Right.
Okay? And those could hit you. Okay. Again, this is rare. And then the other issue might be, a rock coming from some other part of the universe, right?
Mm-hmm.
And the concern is mostly that it's very high speed. And so even though it might be very small, if it hits you, the damage can be substantial. But all of these events are rare. It's just that when they do happen, it can be catastrophic. That's why we have to think about them.
And I understand that you have also implemented some AI systems in your satellites. Could you tell us a little bit more about that?
So what we're looking at there is the orbitless component in the PROSat. To be able to autonomously, for example, make the decision to say, look, something is coming, I should move. That decision making, of course, requires a brain-like system. So that's where the AI comes in. So right now we're exploring some specific algorithms like reinforcement learning that allow us to do some of the maneuvering and some of the what we call attitude control, which is to how to do pointing, that kind of stuff using machine learning. So it's one of the areas that we aiming to be very good at, that is to leverage algorithms to create spacecraft that are more advanced and able to do things more efficiently.
Ooh, and what would be some of the challenges to coming up with a great algorithm for that?
The greatest challenge is the environment. So to create the environment. So, training model requires data, right? So in this case, of course, we cannot send up satellites and train it there, right?
Yeah, right.
So what we need to do is create a synthetic environment that is as good as possible in terms of fidelity, very close to what we'll actually experience in space, but it's on a computer. And then we can run these simulations, we can train it in that synthetic environment and be confident when it goes to space, it will work as expected. But it's very hard to create a synthetic environment because the more refined you need it to be, the more that perhaps you might as well just do the physics, so to speak. Because if your physics is very, very detailed and very, very accurate, then there is no need for a machine learning model. Okay. But at the same time, the machine learning model itself requires a good enough representation of the reality of the real environment, right? So it's balancing these two things. So creating a data, in other words, or a good enough synthetic environment is one of our challenges.
But there's still like a bit of like unpredictability, right? Because it seems like as much as you can create like a synthetic environment here, like you still don't know what would happen there. So like,
absolutely.
Does it feel so like just working in like the space industry, is it something that, like a big part of it is also just like, hoping and praying everything just goes well, because like you said, you can't do the trials in space, right?
Yeah, we try to do our very best here to make sure that we account for things that we know. So, for example, we know how gravity affects our systems, and so we try to have high-resolution models, or we try to use high-resolution models for gravity. But even if you have a very high-resolution model of, say, gravity or magnetic field, there's still events that are unpredictable that would have an impact on you. So, for example, here on Earth, before we launch, all of our satellites go into an environment that simulates the magnetic field of the Earth. Okay, so our studio here in Singapore, we have space where we recreate the magnetic field of the Earth. But then when you're actually in space, the sun can modulate the magnetic field environment in unpredictable ways. Okay, so we are not able to account for that, and that could have an impact such as drag the satellite, and therefore add drag to the satellite, and that's make it come down faster, for example, right? So these sort of natural but unpredictable events, they're very hard to put into a model. So we just hope that it will not have a disastrous impact on our space systems.
You were saying about like how you have a studio in Singapore to, like do all of this. And I guess the engineering and design for your satellites are done in Singapore. But I also understand that these satellites will be assembled in Africa. So what's that like, like managing like your operations across like, like almost like two continents, right? Like it's like Asia and Africa. Like how do you manage it all?
Well, in today's world, I think with the internet, it's not too difficult. But some things that need to be done, we need to be physically together. Certainly, so first we make sure that the tasks are divorced in such a way that the people that I need to physically be with, I can be with. So for example, the design, the prototyping, some of the work that I need to see right here, I'm able to sort of monitor or interact with my team directly. There's some tasks that I don't need to be physically there. And so we make sure that the tasks are set up in that manner. In the Africa operation, the idea of assembly, integration, and testing will certainly require me to go there to some degree, okay? Because it's more of building a factory. So it's not like I have to be on the assembly line myself, but certainly setting the whole operation up is something that I will be physically involved in. So we look forward to either being in Rwanda, in Ivory Coast, or in Malawi. And by the end of this year, we'll have decided on one of those locations.
Right. I mean, it really sounds like what you were saying, like, if you want to build a city in space, or like if just to build a city, you need to, it's not like just one company and it's like bringing like a whole community together. And, now like you working across like, like two continents really shows, you're trying to like get as many people involved.
Absolutely. Yeah. There are millions of people who are educated and not working in Africa.
Right.
Millions. Right. We're not talking of not even 1 million. We're talking of literally hundreds of millions of people. So in other words, they've got the skills and talent, and they're just sitting. Like, but we want to explore space. We have so much work to do as a civilization, and then there are still lots of people who are like, what do I do with my skills? I don't know what to do. So we're trying to say, okay, look, there's quite a lot to do for a lot of people. If I had a magic wand, so to speak, if our company employed, let's say, 8 million people, okay, there's no company that's that big today, okay, but in the overall, that would be a very small number when you do it as a fraction of humanity, right? When you do it as a fraction of the people who are unemployed and so forth. But at that scale, we could go to the moon every week if we wanted.
Wow.
Going to the moon every week.
Yes, that would be a nice weekend trip.
Yeah.
Would you say this would be your way of giving back to, your roots as well, like giving back to the people of Africa as well? Because you were saying like there are quite a number of people unemployed, and by you actually, kind of straddling the operations across these two continents, it really creates opportunities, right?
I hope that it certainly inspires some people to see that things can be done in Africa, and high tech, especially high tech things, right? Because Africa is known for resources and resource extraction and that kind of stuff. Hopefully, through our operation, we can also just be a beacon for building high tech products in Africa.
Hello there, it's time for the mid-roll ad. This Spacetech episode is brought to you by Science Center Singapore. Planning your next vacation? What about taking a trip to space? No passport required. Visit Science Center Singapore and be immersed in Space Explorers The Infinite, the world's largest immersive space exploration experience. Through VR, you'll be transported 400 kilometers above Earth into the International Space Station. On this 1-hour journey, you'll step into never-before-seen 360-degree videos captured in space. Admire mind-blowing views of Earth and explore the daily lives of astronauts. Get your tickets now at infinite-experience.com/Singapore. Now, back to the show.
Well, thank you so much, Christopher. I think now we would like to ask some Paiseh questions. So,
Sure.
Do you know what Paiseh is? I just wanted to check.
I've heard this term many times, so I think I know it. I don't know if I really know it. It's just this.
After today, you can actually use it, regularly. I think Paiseh just means like embarrassing.
Yep.
It's just embarrassing. Like you don't want to ask something because it's a bit embarrassing. Yes. But today we are asking embarrassing questions because as the non-designated science person in this podcast, I mean, Xiaoxin is like, he's probably more familiar with STEM and whatever that
not space science.
Yeah. So he will be joining us in the Paiseh segment as well today.
Okay.
So I think one of the questions that I had is, does Singapore actually have like astronauts? Do we send people to space? Like, is that a thing that we do here? Or like, do we just do satellite stuff?
People, not yet, I believe. I'm sure of it. No, not for people.
Do you plan to send anyone to space?
Can I sign up?
I think, I do think that we will. Galamad. Galamad itself stands for galactic nomad. And so the idea is to be able to initiate a nomadic civilization. So absolutely, we're going to send some people as a company. But right now, it's a little too early because the difficulties of sending people up, just, bigger mountain to climb than sending spacecraft up, which we feel want to get very good at first. Then we'll move to sending people up.
Okay. Do let us know when the job ad comes up because I think Xiaoxin wants to be.
Yeah, absolutely. I mean, what we want to be able to do is to send people to the moon on a honeymoon.
Oh, right.
That's what we want.
Honeymoon.
That's the idea.
Wordplay right there. Okay.
Maybe your grandkids. I think that is quite likely.
I have a question. Singaporeans are usually very conservative and we usually explore careers like being a doctor, being in the public service, for example. What would you say to a Singaporean who is exploring maybe a career in space science or space tech?
Well, first, it certainly is a bigger industry now than it was in our parents' time. Okay, so if your parents were concerned before that there might not be jobs in the space industry, I think that concern is less now because the industry has really grown. So if you're exploring space, you can be confident it will be there in 5, in 10, really in 30 years' time. Because like I mentioned at the beginning, this is a big unexplored region of knowledge of humanity. So your jobs will be there. So it's worth exploring.
Wow. I'm sure with someone leading the frontier like you, people will be inspired to join.
Yes. I mean, he sold me on honeymoon,
Yeah,
like,
honeymoon.
Just the wordplay there.
And weekend trips
To the moon as well. So I really hope Christopher would help fulfill our dreams in that aspect. So we'll play some word association games now. So basically, we're going to throw some words at you actually, and we just want to see what comes up. What's the first thing that comes up in your mind, and then we'll just take it from there. So,
sounds good.
So you ready? I mean, we won't give you much time to think. It's just whatever that comes to your mind. So.
Okay.
Light year.
Distance.
Ah, okay. Distance.
So in very, very light distances are measured in light years. That's certainly the first thing that would come to the mind of every physicist.
Okay, and that there's something that you deal with on the daily basis?
Not on a daily basis. We think about it. We think about how vast the universe is and thinking about distances that light takes billions of years. Can you imagine? It's mind-bogglingly large, the universe we live in. So it's exciting, but also scary.
So does that mean let's say when I see a star or something that's moving in the skies and the time that, in real time, I'm looking at it moving maybe in seconds, right? But actually it's moving at a much different time space because you're saying light years, it's how things move, right?
Yeah, so I think everything you see, you're looking at the past. I mean, also even here, of course, when I look at you, I'm looking at you nanoseconds ago, okay?
Oh, wow.
Because light takes time to come to me. But the farther away it is, the more, the farther into the past we look. So that's how we're able to look back millions of years, okay? We're able to look back billions of years. That's how people are trying to look back all the way to the beginning, okay? What happened in the beginning by looking at the light, okay?
Right. So when I'm looking at the moon, it's delayed telecast in a sense.
Yeah.
It's not.
So when you're looking at the sun, you're looking at the sun as it was about 8 minutes ago.
Oh, it's that's so yesterday.
Okay, so my turn next. Interstellar.
Okay, the movie comes to mind.
Yes. Yeah. Let's go, Christopher.
Okay.
Okay. Do you like the movie?
Don't remember the movie very much, to be honest.
Okay.
'Cause I think I only watched it once and that was it. So I think I'm okay with it. I cannot remember what the story was. I just know that I've watched it.
Are there any like sci-fi movies that you would say it's very accurate in terms of the space scene? Or are they all just like exaggerated?
No, not sci-fi, but a movie that the story could have been interesting is the movie called For All Mankind, which is, I believe, only on Apple TV.
Okay.
And they're sharing about what would have happened if the Soviets had been the first to go to the moon. What would have the United States done? And where would we be as humanity today?
wow.
Right? I think it's a nice arm of history to explore. I do feel that we need to be much farther than we should be, than we are now as humanity in terms of exploring space. Historically interesting to look at what would have driven society if that had happened. But it's not really sci-fi. It's space, but not sci-fi. It's more, I would say, space history.
Okay. So For All of Mankind.
For all mankind.
So if you have Apple TV, please catch it. If you don't, I'm not going to tell you how to watch it. All right.
I think the next word we can try is Milky Way.
The galaxy that we're in, yeah.
Ah, okay.
Chocolate bar. Sorry. Different.
One of trillions of galaxies, but we're here, so we love Milky Way.
Ooh, okay. My turn next. Mars. Not the chocolate bar. The planet.
Yeah, Mars, the planet, comes to mind. We think that going to Mars is a great step forward. As a company, therefore, would like to do whatever we can to support this vision. As I mentioned, there are only a few people working on it right now, too few to do anything meaningful, but I think it's a good step toward exploring beyond Earth.
Is Mars like, because from what I understand, it's the next best place that's habitable for humans. Is that right?
There's a lot of work to do any planet we go to. So our models of what it is, what is required will continue to evolve. But if humanity is set on a particular planet, I think that's better than having us look at many at once. So even though it might not be the best, I think if we pool all of our resources and intellectual resources, so to speak, on this planet, we'll make it happen.
All right. Okay. Last one goes to
Future.
Future.
What about the future? Yes.
The word is future?
Yes, the
Yes.
word is future.
Okay. The first word that comes to mind after future. Future, there's singer.
singer.
There's a singer called Future.
Oh, the singer called Future. Yeah.
That's the one with a PH. Is that the one?
No,
that the
is
same
is
one?
this is a rapper, right?
Yeah.
Like a R&B
Oh.
/ hip hop rapper, Future. Oh, is that like one of your favorite artists?
I've not listened to any of his songs. It just comes on my YouTube. But in my earlier life, I used to rap. So
Wow.
How did this not come up at the start of the
I think it was my mid-teens. It's like something that at least at the high school where I went, it's this sort of rite of passage. At a certain age, you do rap.
Wow.
Oh,
You want
okay.
to impress the girls, so you
on
rap.
top of poetry,
Shakespeare?
Spacetech,
Yeah.
we should add rapper to that list.
Yes. As an impressive way to, I mean, you can impress any girl.
Wow,
Shakespeare, poetry, rap, and also like having your own company. Okay,
That's doing space
yes.
tech. Wow.
So well done, Christopher. Well done.
But you grow up, so now we're doing other things.
Yes.
Yeah.
All right. So thank you so much, Christopher. Like, it's been a pleasure talking to you, like from your time you were growing up to, what satellites are and what of the good work that you do at Galamad Aerospace. We're so excited to see, what you come up with next. And, thank you so much, everyone, for tuning in.
I think for me, it's really listening to you and being renewed with that sense of awe when you talk about space, how big it is and how small we are. But at the same time, we can do something to really push that frontier in science. So that's inspiring, really. Thank you very much. Yeah.
Thank you. It's been my pleasure being here.
Thank you. If this episode has ignited your passion about science, visit Science Centre Singapore to continue exploring the cosmos. Wondering what stars, planets, and constellations are in the skies tonight? Visit Science Centre's observatory on select Friday nights. Admire celestial objects in our live planetarium strolls at the Omni Theatre. Afterwards, join my colleagues for a stargazing session out in the field. More details in the show notes.
And you can follow Void Deck on Spotify, Apple Podcasts, and wherever you get your podcasts to be the first to listen to some mind-blowing conversations with local science changemakers. To find out more about Christopher's work, you can follow Galamad Aerospace on LinkedIn. Alright guys, we'll see you next time. Goodbye.
See you.